1.6 Activity 2. The topic is still average rate of change, so we're calculating slope. For problem 1, it's a math problem about hot water dripping through a coffee maker. We need to just be concerned with units, which are in the table already, and we need to be concerned with the time over which they want us to find average rate of change. So look at number 1. It says to find the average rate of change of the liquid from t equals 3 to t equals 6. So that you stay focused on those two numbers, let's circle the ordered pair where t equals 3 and the ordered pair where t equals 6. Those will be the two ordered pairs we will use to calculate slope. So my ordered pairs again are 3, 11.2 and 6, 14.5. Now I'm going to calculate slope. So the change in y, 14.5 minus 11.2, over the change in x, 6 minus 3. That yields 3.3 over 3, which is 1.1. Now you have to put units on there, and the units are the y units over the x units. We have the change in y over the change in x. So I'm going to look at the units for y. They are ounces. I'm going to write ounces. I can abbreviate that with OZ if you recall. And then minutes. The unit of time is minutes. So there's your answer, 1.1 ounces per minute. In number 2, we have a table again. Again, this is about Joanna jogs on a path. But I'm concerned in number 2 about her trip from t equals 0 to t equals 20. So circle the ordered pair 0, 0 and the ordered pair 22, 40 and calculate slope using that. I'm going to do the change in y. So 240 minus 0 over the change in x, which is 20 minus 0. So that's 240 over 20, and that is 12. The units here are meters per minute for y, change in y, meters per minute, but then notice the x unit is minutes. So this is meters per minute, which can also be written as 12 meters per minute squared. This is how we would represent acceleration. So in the table, the y-coordinates were velocity, and then we're comparing that over time. So it's velocity over time, which is acceleration. So meters per minute squared. For problem number 3, we have the temperature of water, and the time we're concerned with is from t equals 4 to t equals 9. So circle those ordered pairs, and let's calculate the average rate of change. So we're going to calculate slope. 61.8 minus 57.1 over 9 minus 4. That is 4.7 over 5. Put that in your calculator. You should get 0.94. I'm going to check out my units here. Degrees is the y-coordinate measure, and minutes is the x-coordinate measure. So that's degrees per minute. Okay? Okay, next page. Now we get away from the table and we have to use a formula. This is called a model or a function. So we have function f being given to us, 3x minus 6. And this formula here is reminding us of slope. So it's letting you know you're going to have to plug numbers into f. See how this says f of b? You're going to have to plug a number in for x. And here's f of a. You'll have to do it a second time. So there's 2 times we'll have to plug a number into f. So let's get started. They give us intervals. These brackets mean intervals. They actually mean is the x-coordinates are 0 and 3. And it's our job to find the y-coordinates. That's why we have to plug in to the formula for f of x. Okay, here we go. So the first one was 0. So I'm going to evaluate f of 0. And this is where you put 0 back over here wherever there's an x. So I'm going to put a 0 in for x here. So it'll be 3 times 0 minus 6. You might have to use your calculator on this part. That's actually negative 6. So the buddy here with 0 is negative 6. That's your first ordered pair. In order to get the other y coordinate, I'm going to go back to f and plug in 3. So 3, again, we're going back up here, plug it in for x. So we get 3 times 3 minus 6. Well, that's 9 minus 6, so that's 3. I'm going to make that the y coordinate for the second ordered pair. Now you can calculate average rate of change. So I'm going to do the change in y over the change in x. So let's go negative 6 minus 3. So that's the change in y. And then put that over the change in x. So I'm going to go 0 minus 3. 0 minus 3. So negative 9 over negative 3 gives me positive 3. Okay, that was number 4. So now let's do number 5. I'm going to have to find the y coordinates for these ordered pairs. The brackets, remember, mean they're giving us the interval over which we should find the average rate of change. So that interval starts at -1 and it ends at 5. So we have to plug in now to the f function to get the y coordinate. So here I go. F of -1 equals 3 times -1 minus 6, which is -9. F of 5 is 3 times 5 minus 6, or 15 minus 6 is 9. So I'm going to put those in the ordered pair. So -9 goes with -1, and +9 goes with 5. Let's calculate average rate of change. -9 minus 9 over -1 minus 5. That's -18 over -6. That is 3. We got 3 again. Do you know why we got 3 again? Well, let's try another one, see if we get the same thing. The ordered pairs, each of them start with 2 and then 4, because that's the interval. They gave us the interval notation. Plug the 2 in to get the y coordinate that goes with it. 3 times 2 minus 6 is 0, so it's going to be 2 comma 0. And then f of 4, 3 times 4 minus 6. 12 minus 6 is 6. Average rate of change, 0 minus 6 over 2 minus 4. I get -6 over -2. And no surprise, it's 3. Why does it keep coming up as 3? Well, did you notice this function we were given up at the top? That's actually in y equals mx plus b form. It's a linear function. It makes a line. So the number in front of x is the slope of the line. And we know average rate of change is the slope of the line. So that's why we kept getting 3. So I can predict if we get another linear function, we should get the same number as what's in front of x. Maybe in this case, for number 7, it'll be t. So let's see. For number 7, we need the average rate of change on the interval from 1 to 4. That means I need an ordered pair that starts with 1, and I need an ordered pair that starts with 4. So I'm going to plug in h of 1 equals 0.5 times 1 plus 1, which is 1.5. And then h of 4 is 0.5 times 4 plus 1, which is 3. So the other order pair is 4, 3. And let's do calculate the change in y, 1.5 minus 3, over the change in x, 1 minus 4. So that's negative 1.5 over negative 3 ends up as negative half or negative 0.5. Ooh, I need a unit here. The temperature was in degrees Fahrenheit, so it's negative half a degree per, what's the unit of time? You see it? Right there, half a degree per minute. Problem numbers 8 through 10, we're supposed to have a grid in the background. So I'll have to tell you, if you didn't get that in class, what the y coordinates are if you can't see the grid. I used a ruler to draw the grid in and had success that way. So here we are with intervals again. 0 and 3 are actually x coordinates. You simply go to the graph to find the y coordinate, which I think is easier than using those functions, but maybe if your grids disappear, maybe it's not so easy. So 0, negative 2, and then 3, 7 are my first ordered pairs. So the change in y, negative 2 minus 7, and the change in x is 0 minus 3. So that is negative 9 over negative 3, which is 3. Ordered pair for number 9 is 1, comma 1. The ordered pair with 4 is 10. 1 minus 10 over 1 minus 4 is negative 9 over negative 3. Are you surprised that it's 3? What kind of shape is this we're working with? It is a line. So these slopes should all be the same. We're going to use that fact in another activity. All right, the ordered pair is 2, comma 4 and 3, comma 7 for number 10. Here we go to calculate the slope. 4 minus 7 over 2 minus 3 is negative 3 over negative 1, which is 3. So that should not have surprised you at that point because it was a line. Okay, now things change. We have a function once again, but this time the function's not linear. There's a quadratic term in it. So I can't just use a 20. The answer's not just automatically going to be a 20. Okay, so here we go. We're going to have to evaluate, and I'm going to give them to you quickly. So the first ordered pair on the interval is a 1, comma 120, and the second one is 4, comma 360. So I got the 120 and the 360 by plugging in. I'm going to set up a couple of them, but then I have to move along. So n of 1 is 20 times 1 squared minus 20 times 1 plus 120. So that's how I got 120. And then to get 360, I plugged 4 into the n function. So 20 times 4 squared minus 20 times 4 plus 120. And you plug all that in your calculator. You don't have to do that in your head. And you'll end up with 360. So calculating the slope, I'm doing 360 minus 120 all over 4 minus 1, which gives me 240 over 3, which is 80, and the units are bacteria per degree. That's bacteria per degree. Okay, same idea here in the middle. The ordered pair will be negative 2, negative 2. I had to substitute it in there. And then 4, comma 40. And when you calculate average rate of change, negative 2 minus 40 over negative 2 minus 4, you get negative 42 over negative 6, which is 7. Number 13, 0, comma 4, 3, comma 28. Average rate of change, 4 minus 28 over 0 minus 3 is negative 24 over negative 3, which is 8. These slopes will not be the same because we're not dealing with a line. It's a quadratic. For number 14, your ordered pair, when you work it out, you should get negative 1, 0, and 1, 10. 0 minus 10 over negative 1 minus 1 is negative 10 over negative 2. That equals 5. The ordered pairs in 15 through 17 are negative 1, 6, 9, 16, 1, 0, 5, 0.